Now that you guys have tried this on your own, I want to take a look at this together with you. The first question said, is CE a tangent to circle D? Well, we've looked at one of the theorems which talked about if it is a tangent, that we know that this will be a right angle. They'll be perpendicular. And if you look at that, that would be making this a right triangle. So we could really just test to see if this is a right triangle, then we know that this segment would be tangent to that circle because it would be perpendicular to its radius. So really we're trying to see, is that true? Is it perpendicular? So let's check. Because we have a right triangle, we can use the Pythagorean theorem just to test to see, does 11 squared plus 43 squared, does it equal 45 squared? Well, 11 squared gives us 121. 43 squared would give us 1,849. So the question is, does that equal our 2,025? Well, no, it does not. If you add those two together, you get 1,970, which is not equal to 2,025. So because they're not equal, we know that this is not perpendicular. Therefore, we can say that it is not a tangent. Okay? Next one. This one says that BC is a tangent. All right, if we know it is a tangent, we know that it's perpendicular to that circle's radius. We're supposed to find the radius. We're finding R. Now, if you take a look, we have a right triangle. The radius is one leg, 28 is one leg, but if you take a look at this segment, the 14 is only down here at the kind of the bottom part of that segment. It's not listed right in the middle to show that it is the measure of that entire segment. But we do know from A to that circle, that's also another radius. So this whole measure of this entire segment would be R plus 14. R plus 14. So now the question is, it's actually not a question because we know it's perpendicular. We have an equation that we can write. R squared plus 28 squared equals our R plus 14 squared. Notice this is a quantity squared. This is more than just saying R squared or 14 squared. This is a whole quantity, an addition problem. If we think back to our algebra days, we're going to end up having to FOIL this because we've got a whole binomial that's being squared. So this is really saying that I've got an R squared plus, and we know that 28 squared gives us 784. And it's going to equal, when I FOIL this, R plus 14 times another R plus 14. Well, R times R is going to give us the R squared. R times 14 will be a 14R, another 14R, and plus 1,096. Alright, notice that we've got a quadratic equation. We've got R squareds here. But if I subtracted an R square from both sides, they're all canceling out. So the nice thing is, it starts off looking like a quadratic equation, but as we're solving it does become linear. So we have a 784 is equal to, when we combine these two together, we get our 28R plus 196. Well, if I subtract my 196 from both sides, I'll end up with a 588 is equal to our 28R. So if you divide by your 28, we are left with R is equal to 21. So this circle has a radius of 21 units. And you could put those numbers back in. Try your 21 squared plus 28 squared, and you could take your 21 plus 14, that 35 squared, and that should work. Okay, last example. Here we've got two segments that are both tangent to the circle. And the question is to find x. We know that on this one, because these two are tangent to the exact same circle and they share a common external point, we know that x squared minus 4 is the same measure as 21 because they're congruent. If you go ahead and add a 4 to both sides, x squared would equal a 25. So as you square root, x would equal plus or minus 5. Now, could you ever have x be a negative? Well, let's check it. If I try a negative 5 squared is 25 minus 4 is still 21, so both are solutions here.